Welcome to an introduction to statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For more information about Parkbench Tutors, please visit parkbenchtutors.com. In this podcast, we shall be looking at measuring and the use of notation in statistics. There are two important measures to consider. A measure of location looks at how the information is clustered around a typical value. A measure of dispersion looks at how scattered the data is. The results have to be measurable quantities, and the results will have the same units as the data. To illustrate what we mean here, consider these two curves. They have the same spread, dispersion, but they clearly have different measures of location. Here are another set of curves. In this case, we can see that they have the same measure of location, but clearly curve B has a much larger spread than curve A. The most common symbol you are going to find used in statistics is a sign that looks a little like a letter E. It is referred to as sigma, or the sigma operator, or summation operator. Most of the time, we shall simply refer to the sign as sigma. Typically, it is written with three other numbers or letters. Sigma just means add up. So this notation says that we are to add up the values of x. It also tells us that we are going to start at the value of 1 and keep adding until we get to the nth value. Let us have a look at the sigma sign in use. What does this represent? The notation that we have is asking for the first 5 values, from I equals 1 to 5 of x. So we need to add x1 plus x2 plus x3 plus x4 plus x5. Let us take another example of the use of sigma. What does this one ask for? We are asked for the first 4 terms, from I equals 1 to 4 for values of x squared. So x1 squared plus x2 squared plus x3 squared plus x4 squared. You can also express this as n times a. If you are adding a 4 times, it is the same as 4 times a. You should also note that sigma axi is the same as writing a sigma xi. Here is the simple proof of this. Sigma 4xi from 1 to 3 is written in expanded form. This can be written then as 4 times x1 plus x2 plus x3. Sigma xi plus yi is also the same as saying sigma xi plus sigma yi. If we expand sigma xi plus yi from 1 to 2, we can see this quite easily. The expansion becomes x1 plus x2 plus y1 plus y2. The arithmetic mean is written as x bar. The mean is the sum of the items divided by the number of items. So in notation form, this becomes x bar equals 1 over n sigma xi. We will look at a worked example. To find the arithmetic mean of the series 7, 4, 45, 12, 10 and 65, we sum up these numbers and then divide by 6, since there are 6 numbers in the set. So 144 divided by 6 equals 24. To find the arithmetic mean when we consider frequencies, the idea remains the same. We divide the sum of the items by the number of items. In notational form, we express this as x bar is equal to sigma fi xi divided by sigma fi. Sigma fi xi is f1 x1 plus f2 x2 through to fn xn. Sigma fi is f1 plus f2 through to fn. We will look at an example. The table shows the frequencies of 6 different values. The total of the frequencies is 47, which must be the total items. The first thing we need to do is calculate the values of fx for each of the values. Then we sum these to get the total sum of the values. we have sigma f equals 47, the total for the frequencies, and sigma fx equals 268, the total of all the values. X bar will be 268 divided by 47, which equals 5.70. The arithmetic mean is 5.70. Here we have a second example to find a combined mean. The sum of all the values is sigma x equals n times x bar. For group A, the total marks will be 12 times 58, and for group B, 20 times 64. The combined mean will be 696 plus 1280, which we then divide by 32, which gives an answer of 61.5. We can also solve this by treating it as a weighting problem. The weight is determined by the size of the group. Multiply the average mark by the weight of the group for each group, add the results, and divide by the total weight. We still end up with 1976 divided by 32, which gives us the same answer, 61.75. To find the mean for classes, we have to carry out a small calculation to determine the midpoint for each class. The table shows the frequencies for a number of classes. We determine the midpoints, then we can determine the value for fx. These results are shown in the second and final columns. We determine the total for the frequencies and the total for fx. The totals here are 126 for frequency and 3429.37 for fx. To obtain the mean, we divide 3429.37 by 126, giving us an answer of 27.22. If the classes are uneven, we will still use the same method. This example shows uneven classes. We will start by determining the midpoints for each class. Our table now shows we have determined the midpoint for each class. Then we have determined the value for fx, which is the final column of the table. Now determine the totals. The frequency total is 126, and the total for fx is 5252.5. Divide 5252.5 by 126, and we obtain a mean of 41.69. There are occasions when series of large numbers can be simplified to determine a mean. This process is known as coding, and you should always be on the lookout to see if coding can make things simpler. For determining the mean, we do two things to encode: add or subtract a number, then divide by a number to make the set simpler. Calculate the value for the mean of the simpler set, then reverse the process to decode. For example, this set of numbers can clearly be simplified. We start by subtracting 5512 from each number, then divide by 1000 and determine the mean of the new set. Now multiply by 1000 the number we divided by, then add back in the 5512 we subtracted, and we have the mean for the original set. This ends our second podcast on statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, please visit parkbenchtutors.com.